So we need to just finish up some quick issues at the end of Chapter 16. I've stated to you several times that, formally speaking, significance tests require random sampling. Pragmatically speaking, significance tests are often used with non-random samples. My big message to you is that you should go ahead and carry out significance tests with non-random samples. In so doing, you are in essence treating your sample as a random sample from some wider population. Now, you can't draw any statistical conclusions in reality about a real wider population. That's because your wider population is, in essence, an imaginary one that you've construed to give so that you can go ahead and carry out the test. There's no real wider population to statistically generalize your conclusions to. Now, even though that's the case, the significance test with a non-random sample nevertheless informs you reliably about whether chance alone is a likely or an unlikely explanation for your study result. So it still tells you in your particular sample, that is with the particular people in your study, is chance a likely or an unlikely explanation for the study result. And that's the most important information that significance tests reveal. And that's why you should indeed carry out significance tests with non-random samples. Okay, here are some conclusions, all of which go together and have very similar meanings. So if a study sample result is not statistically significant, indeed this is the precise situation when you fail to reject the null. And such a result conveys to you that chance alone is not a highly unlikely explanation for the result. In other words, that the result could well be due simply to chance. When the result is not statistically significant, in essence, that result is not providing strong evidence that the null is false. Now, one of the trickiest conclusions that goes along with the absence of statistical significance, which is to say, accepting the null, is that in this situation, you cannot be confident that the null is true. The prior statement conveys that, your confidence. You don't have confidence that it's false. You don't have strong evidence that it's false. That's not the same thing as saying that you can be confident that it is true. You just don't have evidence that it's false. And then finally, let me just read our formal conclusion, which was the first one that we encountered. So, given a true null, the probability of obtaining the study sample result, or an even more extreme result, is greater than the probability associated with the selected significance level, that is, with alpha. Now, this slide shows a series of conclusions that you can make when study sample results are statistically significant. So, a statistically significant result is indeed the very same thing as the situation in which you reject the null. Further, when the result is statistically significant, a basic conclusion that you draw is that chance alone is an unlikely or an insufficient explanation for that result. When the result is statistically significant and you reject the null, the study sample result, that is the data, is providing to you strong evidence that the null is false and also that the alternative is true. So in this situation, you can be confident the null is false. And then finally, I'll read the first conclusion, the formal conclusion that holds. So when a result is statistically significant, then therefore, given a true null, the probability of obtaining that result, or an even more extreme result, is less than or equal to the probability associated with the selected significance level. That is, it is less than or equal to alpha. Now in closing chapter 16, let me just mention that, the key thing as you think about statistical significance is that you really connect it with its central meaning. In other words, that a statistically significant result conveys to you a result that is unlikely to be due to chance. But what you want to avoid doing, and what some of the particularly conclusion of this text talks about, is don't confuse statistical significance with other important ideas in data analysis. So it conveys to you that the result is unlikely to be due to chance, but it's not per se conveying size of association. It's not per se conveying causality. And further, statistical significance doesn't convey, for instance, whether a result is an important one. Sometimes results that are not statistically significant are important, or it can be vice versa. You can have statistically significant results, and if the content area investigated is not an important one, then chances are that result is not important either. So from this point, what we're basically going to start doing is looking at the many different statistical significance tests that are used in many different situations, and the next 5 or 6 chapters are all about these different tests.